Hi, this is Mrs. Slater, and today we're going to use rational expressions and rational equations to set up word problems. And before we begin, what are some examples of rates? Miles per hour would be one of them because it is comparing two different measurements. You have miles and you have hours, so any two that would compare. Inches per second would be another. And you can come up with lots of different ones for this. And the second thing before we begin the word problems is if a job can be done in 3 hours, how much of the job can be completed in 1 hour? So we would say a third of the job. So keep that in mind when we do this first problem. If a job can be done in T hours, then 1 over T of it can be done in 1 hour. So that's in general what I just asked for, the 1/3. Okay, so then if we have a swimming pool, it has two input pipes. Pipe A can fill in the pool in 2 days, and pipe B can fill it in 3 days. So how long will it take to use to fill the pool using both? Okay, so the first one, pipe A can get the job done in 1/2. So basically, this is saying how much can he get done in 1 day. He can get half the job done in 1 day. And then pipe B, he can get a third of the job done in 1 day. So then we compare this to how much, if they do this together, how long is it going to take them, which is the unknown. We do not know how many it's going to take, so it would be 1 over x. Okay, now the least common denominator for this would be to multiply 2 times 3 times x. That would be the smallest one to use. Okay, so you have 6x to multiply through every single term. And again, just to reemphasize, why we multiply by 6x is to clear the fraction. Okay, so if we're multiplying everything by 6x, it would be 1/2 times 6x plus 1/3 times 6x equals 1x times 6x. And when I cancel, 2 goes in there 3 times, leaving me with 3x. 3 goes into the 6 2 times, leaving me with 2x. And then x cancels, leaving me with 6. So when I add those together, I get 5x equals 6. X equals 6/5. And to say the 6/5 day, not really something that people say. So 1 1/5 day would be a little better. And for both pipes to be filling up the pool. The next one is very similar to the first one. So I would like you to, I'm going to set it up for you, and then I would like you to solve. First of all, Sarah can get the job done in 1/10 of the time because it takes her 10 minutes. Tim can get this job done in 15 minutes. And then how long is it going to take them working together to do 100 pages? So there's 100 pages, and we do not know how long it would take them. So we are going to solve for x. See if you can get 600 minutes. Show your work. Okay, the next one is talking about a ski resort. So there are 5,000 people transported in 6 hours. So there's a rate, people per hour, plus they're saying that that is the tram. And then they say using the chairlift and the tram, so this is together, 5,000 people can get up the mountain in 2 hours. And then the last thing is asking, if the tram breaks, how long will it take the chairlift to bring 5,000 people to the top of the mountain? So that's 5,000, and the chairlift all by itself, I do not know, so I'm going to solve and get the answer there. And again, go practice this on your own, push pause, and see if you can get x equals 3 hours. Okay, and we'll talk about that one tomorrow. All right, and then example number 4, we have 2 hours between Potter and Germantown. And it takes 8 hours to make the trip by bicycle. How long will it take the car and the bicycle to meet, starting at opposite towns at the same time? Okay, so then if we have the bike and then a car, because it's asking you to drive, and then we're trying to figure out how much it is together. And you would go ahead and put the fractions underneath there and solve and see if you can get t, or time, whatever your variable is, 8/5 of an hour, or 8/5 hours, which would be 1 3/5 hours. See if you can get that as your answer. We'll talk about that tomorrow. The next three examples are about things that are in motion. So we're going to have to use distance equals rate times time. So if you have to focus on the rate, distance divided by time will give you the rate. And same with time. If you manipulated this particular equation, it would be the distance divided by the rate. Number 5, you can go ahead and skip that one because it does not use rational expressions. But the next one will. So let's go ahead and start with number 6. A boat or canoe, we're talking about a boat that is in motion. So it's going to require the same motion problem formulas. And a boat travels 6 miles upstream in the same amount of time it can travel 10 miles downstream. Okay, so how we're going to organize this. First, I need you to think of what happens when a boat or canoe is going upstream. Okay, you're going to have the regular rate of the boat, and then what is happening when you're going upstream is all that water is coming to you, so it's going to slow you down. So you're going to have to subtract the current, however fast the current is going. Now downstream, the opposite thing happens, where if you have your current, the speed of your boat, what's going to happen is because that current is behind you and pushing you along the way, you're going to end up faster than what you were going upstream, or just faster than your normal boat speed. All right, so keep that in mind when we set up this box, or this organized chart. So we have distance, rate, and time. And they told us that the distance of the boat going upstream is 6 miles. Now the rate of the boat going upstream, we're going to use this right here, because it's going to affect what the rate of the boat is. So we'll put R minus C. The time, they say, same amount of time. So we're just going to give that a T. Okay, also it says that the same boat can travel 10 miles, so that's 10, downstream, which we know is going to have an effect on the rate. It's going to make it faster, and then the time is going to be exactly the same time, so those are going to be equal to each other. Okay, so let's continue this down here. And okay, now that I have more room, we can continue. They did tell us in the equation, or the problem also, that the rate of the boat is 5 miles per hour. So R, we're going to replace for R in this rate chart. So I'm going to put a 5 here and a 5 here. Okay, so if we are trying to set up an equation, we know that rate is the distance divided by the time. We know the time is the distance by the rate, etc. So let's look at time. Time is going to equal distance. Start with the first one here. The distance over the rate. Time for the second trip is going to be the distance over the rate. And since the time is equal to each other, we can set the equations equal to each other. And then just cross multiply. So 6 times 5 plus C equals 10 times 5 minus C, and you get 30 plus 6C equals 50 minus 10C. And when you solve that, you get 16C and 20. And when you divide by 16, you get 1.25 miles per hour. And that would be the current. That's how fast the current is going to go, which is what they're asking for here. All right, let's try the next one. This is very similar because when the plane is in the air, when it is going against the wind, the wind, it's going to be slower. So the rate of the plane is going to be minus the rate of the current. But if the wind is behind the airplane pushing them along, it's going to be plus. I'm going to go ahead and fix this so it looks better. Minus, and then with the wind is going to be plus. So keep that in mind for the following example. Okay, so let's set up a chart with the distance, the rate, and the time. They tell you a plane can travel 350 miles per hour in still air. So, like I did, don't jump to conclusions and know that that's where exactly it is. So I'm going to write down the rate is 350 kilometers per hour for the plane. With the wind, so that means you're going to have an extra push. With the wind, it flew, that's the distance, 1,000. And with the wind would be the R plus C. In the same amount of time, so both times are going to be the same, but it could travel 750 against the wind. Okay, now the rate is the speed of the plane, and we are just going to plug those in where you see the R. So 350 is going to go here and here. And because time equals distance over rate, we'll be able to set up a fraction for both of them. Time is going to equal 750 over the rate. By setting them equal, it would look like this. 1,000 over 350 plus C equals 750 over 350 minus C. That's supposed to be a 0. Okay, and then I want you to go ahead and solve for C, which would be the speed of the wind. So once you get C, then that will answer your question. Okay, so then look for the current to be 50 kilometers per hour. Try to get that. So you have lots to finish. Good luck, and I'll talk to you tomorrow.